Graphing cube root functions. So we can write it in radical form or in rational exponent form. They're equivalent. But just like yesterday where you had to memorize the pattern for square root, 0, 0, 1, 1, 4, 2, 9, 3, you do have a pattern that we're going to memorize for cube root problems. Start by putting 0, 0 in the middle. And I'm only going to do input values or x values that produce an output that is a nice number. So if I plug in a 1, and I'll come off to the side so everybody can see this. If I plug in a 1, and I asked you, what times itself 3 times gives you an answer of 1, your answer would be 1. The next input that produces a nice output is 8. What value can I take times itself 3 times and get an answer of 8? Now, I just want to clarify something. That doesn't mean that there's not answers. So if you plug in 2, and I'm just going to write over the top, if I write over the top and plug in 2, it doesn't mean there's not an answer. It means it's irrational. It's an ugly decimal. And I only want to graph ordered pairs that are integers. The other ones we need to consider, because we have an odd root, would be negatives. What times itself 3 times gives you negative 1? Negative 1. And likewise, what times itself 3 times equals negative 8? Everything else relates back to yesterday's lesson. So I'm actually going to start right away with a problem that does not involve a scale factor other than 1, but does involve shifting left or right, horizontal shifts or vertical shifts. So let's write this one down. Notice that it is important to include this little 3. The nth root is 3. That identifies it as a cube root, and it tells us what patterns we need to follow. Our first step in graphing this is to identify the new origin. Inside, this says I'm going to shift to the right 3 and up 2. Right 3, 1, 2, 3, and up 2. That is my new origin. Now I'm going to follow this pattern. So there's my 0, 0, my new origin. I'm going to start by first going to the right. So from this point, acting as if this is 0, 0, I'm going to go right 1, up 1, and then right 8 and up 2 from the new origin. And now I'm going to take care of the negative input values. This says go left 1 from the new origin and down 1. Left 1, down 1. And left 8, down 2 from the new origin. So as a reminder, this is continuing to go to the right and moving up. So it's being pulled to the right and up. That's why it's moving at a diagonal. And this is being pulled left and down, and that's why it's going down at a diagonal. Let's go over the domain and the range. There's no limit how far this will go to the right and no limit how far this will go to the left. Negative infinity to positive. Range. Remember, as this moves to the left, it is also being pulled down, so there's no limit how far it goes down. And as this goes to the right, it's also being pulled up, so there's no limit how far it goes down or up. Can you just give me an honest 1 through 5 how well you understood that? Okay, we're going to add a scale factor other than 1 in front. So I'm going to start by finding the new origin. In this case, I'm going to go left 1, down 3. And we can see that the number in front is greater than 1. That means it's going to stretch. It means we're going to take what maybe appears kind of like an S shape, and it's going to rise and fall at a greater rate. So this value needs to be multiplied by the y values. So how this works is, here's my 0, 0. I've taken care of that. I'm going to go to the right. I'm going to move 1 to the right from the new origin, but instead of going up 1, multiply, I'm going to go up 2. Right 1, up 2. And from the new origin, I'm going to go right 8, but not up 2. I'm going to multiply it back with the scale factor and go up 4. And now moving to the left, same concept, go left 1, but down, multiply, down 2. Left 1, down 2, and left 8, and down 4. Domain and range. Once again, there's no limit how far this is going to the right, or no limit how far this is going to the left. When I corrected today's checkpoint quiz, just a friendly reminder on checkpoint quiz. Some students, when they wrote the domain, put positive infinity front, negative and infinity second. Remember, the negative number or the smallest number or symbol has to go first. Range. So as I'm pulling this to the right, it's also being pulled up, and as it goes to the left, it's also being pulled down. No limit how far it goes down, and no limit how high it goes. One to 5? Okay. You're going to work with your partner. You'll have 1 minute to do this problem. You're going to graph it and do the domain and range. I'll walk around. Please make sure you're talking with your partner through this problem. You may begin. I'm just going to draw the chart so when I explain, I'll have this available. One minute, begin. Going to give you an additional 45 seconds. Remember, after you graph it, you're going to identify the domain and range. This is tricky, so if you got this wrong, don't feel bad. There's no penalty for wrong answers. In the past, when I asked students, what number is behind the x? So this is plus some number. Most students say 1. 1 is not the number that's hiding, it's actually 0. So that means don't shift this left or right, only shift up 4 to find the new starting point. This is your new origin. So I've taken care of the origin. Again, this is a cube root function. I have this pattern. Now, this needs to be multiplied by the y values. But let's make some predictions. We already have predicted that it doesn't move left or right and it goes up 4. Because this number, and I'm specifically talking about the 1/2, not the negative 1/2, because it is between 0 and 1, we use the word compress, or it flattens out. So this is going to vertically compress by a factor of 1/2. So it's literally going to take what is considered to be the normal height as you increase, and it's going to shrink it by half. But the negative sign also does something else. What does the negative sign do? It flips it, right? It reflects across the x-axis. It's going to flip, and really this is like our hidden new x-axis when it flips. Okay, so it's our shifted up x-axis. So what I'm going to do now is I'm going to take this negative 1/2 and off to the side, I'm going to multiply each of these by negative 1/2. Half of 2 is 1, and a negative times a negative is a positive. Half of 1 is 0.5, negative times negative is positive. Any number times 0 is 0. Half of 1 is 0.5, a negative times a positive is a negative. Half of 2 is 1, negative times positive is negative. So this is going to be my group of new ordered pairs that I will now graph. So I'm going to start by still going to the right, but now I'm going to go right 1 and down a half. And right 8 and down 1. Oh, I'm having trouble counting. And now I'm going to go to the left 1 from the new origin and up a half. And I will go left 8 from the new origin and up 1. Always include arrows on both ends, insinuating that it will continue to go up and to the left, and in this case, down and to the right. Domain and range. There's no limit how far it goes to the left or to the right. And your range, there's no limit how high this goes on the left and how low it goes on the right. 1 to 5 right now, your understanding of that, 1 to 5.